So far in Chapter 10, we spent our time focusing on how to solve equations with one variable. But if you remember from Chapters 1, 2, and 3, we actually had more than one variable sometimes involved. So what we're going to look at right now is how do I take and maneuver equations around to make them a little bit easier to work with. So here on this first example here, I have a little formula for a tetrahedron. This is called, I believe it's called Euler's formula, and it involves the vertices, the edges, and the faces. So no matter what the shape is, if it's a three-dimensional shape, I can take the number of vertices, so in this case I have on a tetrahedron that's 4, and I can take the number of edges, that would be 6. There are 6 edges here on this shape, and then the number of faces. I can do v minus e plus f, and it always equals 2. Well, for our first example, we're going to look at what if I have a shape that has 8 vertices and 12 edges. How many faces does that have? There are two ways I can do this. I can either substitute these values in, the 8 and the 12, and then solve it, or I can rearrange the variables, solve for a variable, solve for the f variable here, and then substitute the numbers in. Either way will work. So my values here, I have 8 is v and 12 is e, and I'm supposed to find f. So let's do it the first way first. Let's go ahead and substitute. In other words, plug in and then solve for f. So I'm going to write 8 minus 12, so it's the faces, the vertices minus the edges, 12 edges, plus f equals 2. 8 minus 12 is negative 4. So I have negative 4 plus f equals 2. And then to get rid of negative 4, I have to subtract negative 4, which is the same thing as adding 4. Getting rid of a negative is adding a positive. So I have 6 faces for this. The other way to do this, I could rearrange my variables. So I have v minus e plus f. So think about what I'm doing to f. I'm adding v and I'm subtracting e. So what I could do here is I could subtract the v to get rid of it. V minus v is 0 and move it to the other side. So I end up with an expression on the other side of 2 minus the vertices. Then I have negative e plus f. Well, to get rid of negative e, I add e. Negative e plus e is 0. And notice then on the other side, I have f equals 2 minus v plus e. If I were to plug in, the values now, notice 2 minus 8 is negative 6, and negative 6 plus 12 is 6. So either way, I get the number of faces. I'm going to show you an example at the end here where this comes in very useful. It's actually going to be something you use a lot next year in algebra. Okay, so let's take a look at we don't just have to solve for one variable here. I could take the same formula, v minus e plus f equals 2. I could take the same formula and solve for other variables. So here in the first example, I'm going to solve for v. So to solve for v, I've got to add e to both sides to get rid of the e. So that leaves me with v plus f on the left side, and then 2 plus e on the other side, because I added e to both sides. Now I got to get rid of the f, so I'll subtract f, and notice v equals 2 plus e minus f. This is an algebraic expression on the left side. I can't do anything with the e and the f because I don't know what they are. If I knew what e and f were, I could plug in and find the vertices. Next I'm going to solve for e. So that means I'm going to get rid of v first. So that leaves me, I'm going to subtract v from both sides. So you have negative e plus f equals 2 minus v. And then I got to get rid of the f, so I'll subtract f from both sides. And that leaves me with 2 minus v minus f. But it also leaves me on the other side with negative e, which is the same thing as negative 1 times e. So I'm going to divide by negative 1, because notice a negative divided by a negative leaves me with positive e. 2 divided by negative 1 is negative 2. Negative e divided by negative 1 is positive e, and negative f divided by negative 1 is positive f. So there we solve for e. Just kind of canceled out those negative signs there. All right, using different operations. Here I have multiplication. Okay, so I'm going to divide. Notice h is being multiplied by negative 1/2 b. So I'm going to divide by negative 1/2, or by 1/2, not negative 1/2. Notice if I divide by a half, that's the same thing as multiplying by 2. So that's going to leave me with 2a divided by b. b stays in the denominator, leaves me with h. On the other side here, I'm going to solve for a. So I got to get that b squared on the other side. That's the Pythagorean theorem. So I have a squared equals c squared minus b squared. Those are my hypotenuse minus the leg squared. Opposite of squaring something, take the square root. So I'm going to take the square root of everything on the right side. So a is the square root of c squared minus b squared. That would give you one of the legs. All right, the formula for surface area of a cylinder. If you remember, there are two circles on the top and the bottom. Well, the circle is pi times radius squared. Since there's two of them, I'll do times 2, top and bottom. And then the lateral area around the side is the circumference, 2 pi times radius times the height. I'm going to solve for h. So the first thing I'm going to do is get rid of this pi r squared times 2. Since I added it, I can just take that whole thing and subtract it from the other side. So I'm going to take the surface area and subtract pi times radius squared times 2. That leaves me, on the other side, with 2 pi r h. Those are all multiplied together, 2 times pi times r times h. So that means since they're multiplied, I can divide by what I'm multiplying h by, which is 2 pi r, or circumference. So here, this whole big long block of numbers and letters is what the height equals. All I'd have to know is what's the radius and what's the surface area, and I could solve for the height. So let's get into how this is actually used in algebra. We're going to solve and graph. So I could plug in numbers. Remember, I plug in numbers to get ordered pairs. In algebra, it's going to be very useful to solve for y first. So notice the process I'm using here. I subtracted 2x. That leaves me with 3y, so I'll divide by 3. And notice 6 minus 2x, the whole thing is divided by 3, not just the 6. So this is going to be 6 minus 2/3 x. Alright, so now what I need to do, remember when I graph, I have to plug in numbers for x to figure out what the y values are. I'm going to plug in 0 because that's an easy one. 2/3 times 0 is 0, so that leaves me with 2 minus 0 is 2. I'm also going to plug in 3 because notice when I multiply 2/3 by 3 over 1, that gets rid of that denominator, gets rid of that fraction. So I end up with 2 minus 2. So y equals 0 when x is 3. So I have two ordered pairs here. My ordered pairs are 0, 2 and 3, 0. I'm going to draw a little xy axis here. I'm going to graph my two dots and then connect them. Notice it was a little bit easier to get the math here because I isolated for y. Again, when you get to algebra next year, there's going to be a whole nother reason why it's important to isolate for y. For now, we just want to have practice in solving for these variables. There you go. Put the arrows on the end to say it goes on and on forever. And there you have it. You're going to have quite a bit of practice with this to make sure that you know what you're doing, and hey, this is kind of a difficult concept. So good luck. Let me know if you have questions.